In this video, we are going to talk about working with math functions, in particular, working with function notation. First of all, what is a function? You can consider a function to be like a math machine that produces an answer based on some inputs. So here's an example of a function. Don't focus too much on this notation. That's the function notation that we will cover in a moment. But here's the heart of our function, 200h plus 50p. In order to use this function or machine, we need to know what h and p are. So we call those inputs. H is equal to 3, p is equal to 30. Once we know that, we can substitute and do the math. 200 times 3 plus 50 times 30 is going to give us our answer. We evaluate that in the calculator, and we get our answer of 2100. That's all there is to it. So let's take a look now at that function notation. Here's an example. F of x equals 4x minus 10. Now, the right-hand side of this equation probably looks pretty familiar to you, but this left-hand side, which is the function notation, looks kind of weird. What does this f of x mean? Well, it's really the same as the y that you've seen before. Y equals 4x minus 10 probably looks very familiar to you, but we've basically replaced y with this f of x. So let's explain why somebody might do that. It's just another way to write an equation. There really isn't much of a difference between these two. F of x just means there is a function and its name is f, and it depends on the value of x. That's all it means. Functions can use different function letters and variables. For example, we could say g of a, the function g depends on the variable a. C of x comma y. The function c depends on the variables x and y. A function can have more than one variable. Here's another one. A, and here we have a capital A. It doesn't matter whether we use a lowercase or a capital letter for our function. The function a depends on the variable r. That's all there is to it. Let's take a look at some kinds of problems that you might use functions in. One form of a question gives you the function and then asks you for the value at some specific number that you are given. An example, for the function f of x equals 2x plus 50. What is f of x when x equals 100? All we have to do is substitute 100 for x. X equals 100 into 2x plus 50. That gives us 2 times 100 plus 50. 250 is the answer to that. Again, the math is usually not that complicated, but the notation can be a little confusing. Here's a different way that the same kind of question could be asked. For the function f of x equals 4x minus 25, what is f of 50? F in parentheses 50. Well, all that means is that we should treat x as 50. The variable that the function uses is 50. So it just tells us that x is 50, and then we proceed as we did in the previous example. Just substitute x equals 50 into 4x minus 25, and we get 175. 4 times 50 minus 25, if you're following along with your calculator, will give you 175. Now, there's word problems that will involve functions. These tend to involve a lot of words, so it's important that you be able to identify the part that you need. So that's what we're going to focus on these two word problem examples. So the first thing is to identify the function. The monthly cost function for a broom manufacturing business is C of x equals 5.25x plus 5,000. So let's pull that out of this word problem because that's our function. So because of what we just went through, you realize that what we need to know is the value of x. If we're going to use this function, we need to know the value of x. X is the number of brooms that they make in a month. What is the monthly cost if they make 1,000 brooms? So all of these words basically gave us this function and told us that x equals 1,000. So now we're in business. 5.25, do this along with me, times 1,000 plus 5,000. You're probably done already. 5.25 times 1,000 is 5,250 plus 5,000, I'm doing this by hand, is $10,250. That's the answer to this question. The monthly cost will be this if we make 1,000 brooms, because this is the monthly cost function for the broom business. So that's it. Let's look at one that's slightly more complicated. The function for the height of a ball in feet thrown straight up in the air is h of t equals -16 times t squared plus 60 times t, where t is the number of seconds after the ball is thrown. What is the height of the ball 2 seconds after it's thrown? So, kind of more confusing. We have a more difficult function here, but the process is exactly the same. Let's pull our function out because that's the most important part of this problem. 16t squared plus 60t. And we know that now that we've identified this function, that what we need to know is t. What is t? What did our word problem tell us t represents? It's the number of seconds after the ball is thrown. And this tells us we're interested in 2 seconds after it's thrown. So we substitute 2 in for t. So we get 16 times 2 squared plus 60 times 2. And the answer to that is 56 feet, because this function is calculating the number of feet a ball is in the air, the height of the ball in feet. All right, that's it for this video on functions. Now it's time for you to do some practice on your own.